Hey guys, welcome back. We're going to be looking at chapter 6.9, curve fitting with polynomial models. Okay, it's the title of the video you've just decided to look at. Let's see if we can make this efficient time-wise. So here we go. All right. Use finite differences to determine the degree of polynomial that best describes this data. This is really nice. It's telling you what to do, use finite differences. You probably forgot, so let's look at it together here. Okay. All right. I'm just going to call it 1D. All right. First difference. All right. We've done this to prove quadratics or not. Okay. If data match quadratic data through this method, so follow along here. All right. Let's see here. To go, we're going to focus on the y values. To go from this value to this value, we need an increase of 5. From this one to this one, a decrease. Okay, from this one to this one, a decrease. From here to here, a decrease of 42. And if you can't do the mental math, hey, there's always that calculator. Alright? So here's where we're at. Right? Now there's nothing too significant there, but if you look back at your notes, okay, of when we work with quadratics, the important thing is, is there a constant difference? Okay, all right, so that's what we're looking for. Second difference, from here to here, okay, there would be a what? A decrease of 19, right? Next, excuse me, to go from here to here, we need what? A decrease of 16. Right? Notice the way I'm describing this, because you do want to, it can get kind of tricky whether to add or subtract, but to go from here to here, what do you need? A decrease of 12. And to go from here to here, you need a decrease of 7. Right? Again, the main thing is does there seem to be a constant difference? Not really. So let's keep marching. Again, these are just random polynomials, so that the investigation has to go a little further. Okay. From here to here, we would need an increase of 3. From here to here, we need an increase of 4. And from here to here, an increase of 5. Right? Now, as you can see, this is kind of constant. It's a lot closer than these. So some people may stop there. But if it's going to take little effort, see if you can go a little further, unless they're all exactly the same, and see what happens. From here to here, we get a 1. From here to here, we get a 1, and bingo. This bad boy indicates a constant difference. Right? Now, the fact that it took us 4 differences, we now can say that this would be a polynomial, okay, of degree 4, okay, and in parentheses, we should reflect on the names. This would be a quartic. Okay, just a general quartic polynomial. Quartic. And I like the symbol, the double P like that. Okay, or it's a P with a double back. That'll take care of having to write the word polynomial. Alright. Let's look at this next one. The table shows the population of endangered tigers from 0 to 20 years. Write a polynomial function for the data. Alright. So where can we start here? Alright, we have to actually create a polynomial in which this data fits almost perfectly. Alright, let's go ahead and get an idea of what kind of polynomial we're working with. So you should be thinking, well, how high of a exponent? What's the highest, right? What's the degree? Well, let's investigate this. Let's use this last method. Okay, from here to here, let's do some mental math. You would need 157 increase. How about from here to here? Okay, you would add 134 units. What is the change here, the difference here? And lastly, from here to here. Alright. Not very constant again, and I'm using that word again and again so it sticks. So we keep on marching. Okay. To go from here to here, let's go ahead and drop 23 units. From this one to this one, Let's go up 76 and here to here 173. Okay. Again, not very constant. We definitely got to keep marching. And from here to here, all right, we're going to need an increase of 99. From here to here, 97. Okay. So because we're kind of running out of differences that we can process, this is pretty good. Okay. Not great, but pretty good. So I'll put a question mark here just to remind you that it's not the most constant, but I'll tell you what, it's pretty darn close. So what does that, I'll ask the question, what does that tell us? Okay. You should be thinking that, okay, to use the same kind of notation here, right, that we have ourselves a polynomial roughly of degree 3, okay, and it's some kind of general cubic polynomial. Alright, unfortunately we're not done, right? What does it say? Write a polynomial function for the, so it needs the actual polynomial. Okay, I'll show you why this is important nonetheless. So here we go. Okay, the trick here is to go calculator and enter these values. So we've done this before, so let's kind of review here. Okay, 0, 5, 10, 15, 20. Okay, we're gonna go. Let's go home. We're gonna come here where we've been before. And although there's different ways to get here, I think this is the most easy to explain. Okay. So lists and spreadsheets. Darn it, I forgot. 0, 5, 10, 15, 20. 0, 5, 10. Alright, let's move on over here. Geez, these aren't going to be that friendly, right? 284.37. Geez, can make a mistake here. Darn it, right there. 571.781. Okay. And lastly we have what? 1164. It had to be a big number, didn't it? Alright. Now, if you remember, we're going to try and plot this data. So you must give this data, this list of data, a name. So now what I'm going to do, although you could do different things, I'll just go home, keep it simple, move over to the right to data and statistics, hit enter. And here's this familiar guy. Tab will do the trick. The bottom is typically the x-axis, hit enter. Tab again, down. Going up is the y-axis. And I've got my data, right? But long story short, we need a polynomial. We're very close. We've got our data plotted. Now we go old school regression, right? Menu, 4, 6. And that work we did for what? Although all these would provide some kind of function, specifically ours should be, or at least more to the point, a cubic. And there we go. Alright. So this bad boy here is essentially what we're going to write down. So let's see here. Now there was kind of a curvature there, but anyways, let's see here. I'm just going to go one decimal spot, so 0.1 x cubed. Alright. 0.1 x cubed. Let's go back here. Then 2.4 x squared. Alright, let me get over here. Then 40.2x. Right. And Okay, the rounding, that's not the point. We're way too exact at this point. 280.0. 280.0. All right. Let's see here. Dun, dun, dun. And we're done. Okay. Let's look at this last one. What quartic function does the graph represent? Alright, there's different approaches to this one. So, what can we do here? Alright, well, they're calling it a quartic function, so there's what? Right, this is a degree 4, there must be 4 zeros, and luckily they're all real. Apparently none are imaginary. So, let's just cut to the chase. We've been here before. Okay. Remember, just yesterday we were given problems where they gave us some of the zeros. Others were implied. Well, this one's a little more straightforward. They're just illustrated. So let's take a note of who these guys are. -2. Okay, this one's -half. And half. And this one's about 1.5. So let's call it 3/2. Alright, remember these were given, and what did you guys do? Right? So you've got a polynomial with the given zeros. So we can simply create our skeleton. 1, 2, 3, 4. Okay, it's a lost art. It's kind of sad, but you know, stick to your guns with those good habits. Okay. Now all I got to do is insert. Okay, I'll go a different color. Why not? -2 makes this a +2. Bring this guy down. Oh, jeez, how did I forget that? Minus and minus. So bring him straight down. That forces this guy to be a +half. Bring him straight down. That stays a -half. And this guy comes down as a -3/2. Alright, so technically we're done. Alright, there is that polynomial, or that quartic function that represents this graph. Let me give you a little tip come test time, just in case. If you've got a whole number like that, awesome. If you don't, here's the quick fix to survive. This one's intact, done. This one is not intact, so here's all you have to do. Okay? Well, now we can talk about the why in class, but for now, okay, in terms of survival mode, all you have to do is multiply both of these by this denominator, which gives you a 2x plus 1. This guy, same thing, right? Multiply by 2 the denominator, so you get 2x minus 1. And here, what would you do? Okay, hopefully you said multiply by 2 also to get rid of this denominator, so you'd be with 2x minus 3. Alright guys, thank you for your time. I'll see you in class. Hasta luego.